Hello friends, in today's session we are going to see how do we plot the linear equations in two variables on a graph. So friends, now we'll look at the geometric representation of the linear equations in two variables. We already know that the linear equations in one variable have a single solution, that which means one particular value of that variable satisfies that equation. So we plot that equation on a number line. We don't do it on a coordinate plane because the solution is just one fixed value of the variable which can be marked as a point on the number line. But when we are talking about the linear equations in two variables, now here there'll be, we've already talked about it, that this linear equation has multiple solutions. Now another important thing to note here is that the linear equations, as the name suggests, linear itself suggests that the kind of graph it will have will be a straight line. So the name linear equation comes because of the graph which it has. So linear equation has a linear graph on the coordinate plane. Now we'll first of all write a few possible solutions of the given equation in this kind of a table where we have x and y. So we have these two variables and we'll write in each column, we'll write a value of x and then we'll find the corresponding value of y and write it below it. So the values will be such that they satisfy the equation, and similarly we'll have another value of x, another corresponding value of y, another value of x, another corresponding value of y, and as many values of x, and then we find the corresponding values of y. But it is important to note that since we have the graph of a linear equation, we know is a straight line, so we need 2 points, we need 2 solutions of that equation to be able to draw the graph. So here we take an equation 2x minus y plus 1 equal to 0. We take this as an example and we'll plot this on the graph. So let's first of all take x equal to 0. So for x equal to 0, we know that x is 0, it becomes 0, minus y plus 1 equal to 0, so y becomes 1. So now we can plot this point 0, 1 on this axis, on this coordinate plane. So we say x is 0 and we say y is 1. So this will be the point. Now we take the value of x as 1. So we get 2x becomes 2. So we get 2 minus y plus 1 equal to 0. So we are saying we get y equal to 3. So if we put this value of 3, we get 2 minus 3 plus 1 equal to 0, which is true. So we are saying for x equal to 1, we get y equal to 3. So this is the point that we have. Now we can take another point where we take, say for example, we take x equal to 3. Now if we take x equal to 3, we have 2x equal to 6 minus y plus 1 equal to 0, which means y is equal to 7. So we are saying for x equal to 3, we have y equal to 7. So we plot this over here. So now we can connect the 3 points. We can just join these 3 points and we'll see that it comes out to be a straight line, and we can actually extend it on both the sides and we can say this is the graph of the given linear equation. So any point on this graph is now a solution of the linear equation in two variables. So although we've plotted 3 points here, we can plot 4, 5, but the minimum number of points is 2, and 2 points are sufficient to be able to draw the graph for linear equations in two variables, and it is sufficient only because we know that the graph for a linear equation in two variables is a straight line. For any other equation which is not linear in nature, we cannot draw the graph by just taking two solutions. So now, friends, we're going to find area between the graph of a linear equation and the coordinate axis. So let's now take an example, equation of 2x plus 3y equal to 12 on the graph. So now let's find out two different values of x and y. So we are saying we will find two solutions. So let's say x we take as 6, and we know we get y equal to 0. So now we need to take another value of x and y. So we can take x equal to 0 and y equal to 4. So we are saying these are the two solutions of the given equation. So we'll first of all plot that on the graph. So we are saying x equal to 6 and y equal to 0 is one solution. So this is 1, and x equal to 6 and x equal to 0 and y equal to 4, this is the other solution. So we can simply join these 2 points and extend it if we want, but for finding out the area, in this case we don't need to extend it. Now we need to find out the area bounded by the coordinate axis. So this is the bound by the coordinate axis and the graph. So we are saying this is the area that we are interested in finding. So this point where the two axes meet is called point A, and we call this point on the x-axis as point A. This point is O, point A, and then the point on the y-axis we call it as B. So now we need to find out the area of the triangle AOB. And since we know that the axes are perpendicular to each other, we will just find out the area of a right angled triangle using the rule half into base into height. This is the formula for finding out the area of any triangle. So now we know that base is OA, which is 6 units, and we know the height of this triangle is OB, which is 4 units. So we can say that the area is half into 6 into 4. So we'll cancel this and we get 12 unit square, 12 square units. So this is the area which is bounded by the coordinate axis and the graph of the linear equation in two variables. So now the question here is, why did we take the solution of this nature where either x or y is 0? Could we take any other possible solutions for x and y? Say for example, we take x equal to 3 and y becomes 2 into 3 is 6 plus again y equal to 2. So we could get this solution also where x is equal to 3 and y equal to 2. Why did we take these kind of solutions? See, the point here is that when we are trying to find the area between the graph of a linear equation and the coordinate axis, we have to make this triangle where the graph cuts the x-axis and the y-axis, and then we get this triangle and find out the area. So we are anyways interested in finding out these 2 points. So that is why we've taken these solutions. But otherwise, even if we take the solution of the type 3, 2, which is actually here, it is okay to take any 2 points and draw the graph and then extend it and find out these 2 points, so that the points where it cuts the x-axis and the y-axis, which are called point A and B here, and then find out these values of these points and then find out the area. So it is okay to take any two solutions and draw the graph, but to find out the area, what will be required is these two coordinates, coordinate of point A and coordinate of point B, so that we can find out the base and the height of the triangle. So friends, now that we've seen what a linear equation in two variables look like on the when plotted on a coordinate axis or coordinate plane, the question that comes to our mind is, why do we plot it on a graph? What is the need to do that? So first of all, every solution of the equation is a point on the graph representing it. So this is, as we've been discussing in the previous, as we were drawing the graph, that every solution of the equation is a point on the graph representing it, and conversely, any point which lies on the graph satisfies the equation. So we are saying if we have this graph, we can, if we've just drawn this part of the graph, so we can say every solution that we possibly find out has to lie on this graph, either the part of the graph that has been drawn or the extended graph. So it has to lie on this, and conversely, even if we've not found that as the solution, but if we mark any point which lies on the graph, we are sure that it is a solution of the equation. Now, a graphical representation is very useful in showing a relation between the two variables, especially for overviews and presentations. So now supposing I write an equation of the type x plus y is equal to 4, or a second equation I write 2x plus y equal to 5. Now these two equations do not show me a relation. It just by looking at it, I will not be able to figure out which one of these two may be a better scenario to have. But if I have these two graphs, the one that is drawn here and say this graph, then just by looking at the picture, looking at the two graphs, I can figure out which graph would be a better graph to have. Say for example, we are saying that as the time increases, the cost is decreasing. Now, if we are saying the cost is decreasing fast as per this graph which is drawn in the purple color, this graph, and in the graph in the black color, the cost is decreasing slowly. So, if we are talking about reducing the cost of a certain commodity, I know that this purple graph is better than the black one. So by just looking at the graphical representation, it is easier to find a relation between the two variables and decide which would be a better approach to take. Similarly, supposing we had something like, a y equal to x kind of a graph, and we are saying a y equal to 3x kind of a graph. So if we were to show it, I would say y equal to x graph would be something like this. But if I were to say y equal to 3x, so the graph would be more steep. So if you're talking about the profits, that the profits are increasing as shown by this graph where y is equal to 3x, I'm saying this is a better scenario to have. For a business, the profits are increasing faster. So this graphical representation gives you a better overview. Graphical representation is also useful when you want to compare two equations, as I just mentioned in the above cases. In both of these cases that we discussed, where we have x plus y equal to 4 and 2x plus y equal to 5, or these two set of equations where we have y equal to x and y equal to 3x. So it becomes more useful when we want to compare the two. Now, a very practical example would be in a cricket match, you would normally see that supposing one team has already played and the second team is playing, there's a line graph which is shown for the first team, and the graph for the second team is shown as it progresses, and there's an extended graph which is shown that if the second team continues to play at the rate it is playing, where would it hit? So it gives you a graphical comparison between the two situations. And we just talked about how to find out the area under the graph. Where do we use that? We use that very significantly in science for many calculations. Say for example, we have a velocity time graph which is given to us. So by finding the area of that graph, we can find out the displacement of the scenario. So these are the certain cases where plotting a linear equation in two variables on a graph, or for that matter plotting any equations on a graph, helps. That is where it becomes more handy, and that is why we do that. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.